Oh, hi Simon. Hi, nice to see you. How are you?
Good.
Good. So we would like to show you a bit our company, Digatron Systems. So please welcome in. Yeah, so here, this is our hall, our reception. And then we have the cafeteria there. We have a meeting room there. And then we can go to the technical department. Yes. So here we have our technical department where our mechanical engineers, software engineers, and electrical engineers are. We have also our purchasing department here. And basically here we design our machines and our software and power electronics. Then we can move to our power electronics lab. Yes, so here we have our power electronics laboratory. So we design our boards, electrical boards, and we also write the firmware software for the boards. So our power electronics is fully designed in-house, and we use this power electronics for the formation equipment. So for our formation chamber for cylindrical, pouch, and prismatic cells. Now we can move to the shop floor. So here we have a dry room that can go up to minus 50 degrees C, and we have the possibility to work with new materials like lithium metal, and we do like some testing with these materials. One example is laser cutting of lithium metal. Then we do also tab welding. So we can do a lot of, let's say, new experiments for the lithium metal and for all the materials that need to be in a dry environment. Then I would like to show you some of the other machines that we have. Welcome to the shop floor. So here I would like to show you the swapping machine. So basically here we have as an input material a tray with the cells. Okay. And then we change the cells from this tray to a new tray that will go into the formation chambers. So we swap the cells from one tray to another. By doing so, we need to do, of course, a lot of checks, and so we do a lot of controls about the cells, and we change the position of the cell from, in this case, from horizontal to vertical, because this is a, let's say, special project where we had some customization for the customer. Then we can move to the Z-stacking machine. So here you can see our base Z-stacking machine, where we are basically stacking the sheets of the electrode on top of each other and doing the Z-folding with the separator. This machine applies also tapes to secure the stacking position, and then we have the unloading of the stack. Of course, here we can also do the wrapping of the stack, and we can, the operator can program the number of wraps that are done on the stack. Here you can see the loading of the anode and of the cathode. And here we have, of course, the control systems to align the anode and the cathode before placing into a stack. So we have a pick and place with the active alignment and position control. The tape can be applied as a number of tape as the operator and the customer wants. So we are flexible. We can apply the tape on the top or also C-shaped tape. And of course, as I mentioned, the wrapping of the stack can be programmable. So now we can move to the cylindrical cell assembly machines. So we'll show you the welding machine and also the grooving machine for the cylindrical and the crimping. So basically here we do the welding of the tab. So here we are talking about a cylindrical cell assembly machine for with the tab design. So here we have welding of the tab, then we have grooving, so we do the beading of the can, and here we have a final laser welding. So laser welding is all the solution is integrated by us and developed by us. After the laser welding, we go to the next machine here, where we basically have the crimping and the filling. So also in this case, it's all designed by us from scratch. And for example, the filling, we can dose the amount of electrolyte with high accuracy, high tolerance, and all the pumping system is designed by us. And we apply this technology, of course, to the filling of a cylindrical cell, but also to the filling of pouch and prismatic cell. Very similar with the laser welding, we have developed this technology, and we can apply it to various formats, so cylindrical cells and also prismatic cells. So we can do the welding of the lid to can, bus part to the lid, and of course the final laser welding of the lid. So basically here on my back you can see how we start the assembly of these machines. So of course here you see the frame. In this case we are talking about a cutting machine with high speed. So it's let's say medium productivity in our portfolio. And here you see one cutting machine for the anode, one cutting machine for the cathode. And then of course on this then we build the frame, and then we do the assembly of all the functional groups of the machine. So for example, in the next machines there, which are for pouch assembly line, you can see some of the components that are being assembled. So we can move there if you like. Yes, so for example, here you will see this shuttle. This machine is being assembled, is for pouch sealing. And here it's basically all automatic. So we have the sealing of the cell and also the cutting of the pouch. And of course here is during the assembly, so you can see some of the parts that are being assembled. So basically this is the starting product, so it's the can 4680. Then we have the beading or grooving that we do there. And it's a rotational grooving approach. And then we have here the final cell with the crimping of the lid. Yes, so at Digatron we have two product lines mostly. So at Digatron Systems we have cell assembly lines that I showed before, and formation equipment. For cell assembly lines we have laboratory lines and pilot lines. For formation equipment we have laboratory formation, pilot formation, and mass formation. So we have developed a modular concept of a formation module, and we can replicate this from the lab all the way up to the mass formation. Here you can see, for example, a laboratory formation where in this case the product to form is a pouch cell, and we have the possibility to work with trays of pouch cells that are compressed or also uncompressed. Usually with pouch is compressed, and the same can be also with prismatic cells. So we have compressed tray and uncompressed tray, and as you can see there we have the contacting system. In this case we have an axial cell, and of course we can have the contacting system from the sides, and in case of prismatic also from the top. And the same for cylindrical. So we have developed different contacting system for all the cell formats. So for cylindrical is from the top and from the bottom, or can be also both from the bottom for example tabless design, and for prismatic we have from the top. Here we have from the side for pouch. Our system is completely integrated with power electronics. We have a safety handling system where we flush with inner gas in case of a temperature rise or smoke. So we have smoke sensors, and so we have all a safety procedure in case of let's say hazardous event. And also we have the possibility also to extract the gases during the formation. So we developed also systems where if the cell is degassed during the formation, we extract the gas. So this is also possible, especially for big cells like prismatic. We work with different formats, as mentioned, so prismatic, pouch, cylindrical, and this is really important for us to be flexible in our machine to be able to work with the different cell designs.